Hello, this is Mrs. Huntley. This is Module 4, Lesson 26, Characterization of Parallel Lines. And your essential question for this lesson is, what does it mean if the graph of the equations produce a set of parallel lines? So we're still working with systems of equations, we're still working with graphing, and now we're just interpreting the graphs when we take a look at them. So both of these equations are in slope-intercept form, so they're pretty easy to graph. Just to remind you, slope-intercept form, y equals mx plus b. B, that's your y-intercept. Your beginning, where you're starting from. M, that's your slope. That's how you're going to move after your beginning point. So in this first equation, my b is at 4, so I'm going to make a nice dot there. My slope is 2/3. Remember, slope is rise over run, so I'm going to rise 2 and then run 3. Not big enough for me to do a second point, so I'm going to go down 2 and then left 3. I like to have 3 points to draw a nice straight line. And gets an arrow on it. Let me straighten that out a little bit. It's a little bit off. There we go. Good. Okay, the next one, I'm going to make this one in green. And my b is starting at -2. And my slope is 4/6. So rise 4, 1, 2, 3, 4, and then run 6. 1, 2, 3, 4, 5, 6. It's not big enough for me to do it again, and it's not big enough for me to do it on the bottom, so I'm going to have to suffer and make a nice straight line with only 2 points. I did it. Okay. Now, what happened? We've got parallel lines. What do we know about parallel lines? Well, first of all, we know parallel lines will never, ever, ever cross. And we said in the last lesson that the point at which the system of equations, the line crosses, is going to be the solution. So what does it mean if we have lines that never, ever cross? You got it. There's no solution. There's no number, no real number, that will satisfy both equations at the same time. Now, that doesn't mean that the equation itself doesn't have a solution. Each equation has some solutions. It's just there's no numbers, there's no ordered pair that I can plug into both equations that will make both equations true at the same time. So let's take a look at what else we can say about these. I said my slope here was 2/3. My slope here is 4/6. Now 4/6, I can reduce that fraction. If I divide my numerator and my denominator by 2, I'm going to get 2/3. So what ends up happening is my slopes of both of these lines are the same, but my y-intercept is different. Okay? So the slope of the first equation, I said, was 2/3. And the slope of the second equation, I said, was 4/6. And 2/3 and 4/6 are equivalent fractions. So I can put an equal sign in between them. They're equivalent fractions. Okay. Identify the y-intercepts of each equation. So my blue equation, I had a y-intercept of 4. And my green one, I had a y-intercept of -2. Now 4 and -2 are not the same. Therefore, they're going to be crossing the y-intercept at a different place, but they're going to be rising and running at the same rate. So the slopes of each equation were equivalent. The y-intercepts were different. That means you're going to have parallel lines. That means that those parallel lines are never, ever, ever going to cross, and there is no solution to this system of equations. Let's move on to another example. Okay, both of these equations are in slope-intercept form. Oh, they actually even have equivalent slopes right here. You can tell that they're equivalent. What I'd like you to do is go ahead and pause the video sketch the graph of both of these lines, do them in different colors, and then answer the questions that follow. Pause the video, please. That's not what I wanted to do. Okay, so I have both of the equations graphed. You can see that they are parallel lines. Identify the slope of each equation. See, my blue one has a negative 5/4, and my green one also has a negative 5/4. Those are equivalent. The y-intercept, the blue one has a 7, the green one has a 2. Those are not equal. So what can we say about this? So I thought I had some typing here. And apparently I do not, so no solution to this system. Okay, the slopes are the same, the y-intercepts are different, therefore I have parallel lines, and that means there is no solution to this system of equations. We know parallel lines never ever cross. If they never ever cross, we never have a point that would satisfy both equations at the same time. Hopefully this is making sense to you. You can go ahead and do number 3 on your own. Pause the video, and I will sketch the graphs, and then you can come back and check your work. So pause the video right now. Alrighty, check your graph. Your graph should look like mine. The slope of each equation, the blue line, I've got a slope of 2. The green line, I have a slope of 2. The y-intercept, the blue line, my y-intercept is at negative 5. The green line, my y-intercept is at negative 1. The slopes are the same. The y-intercepts are not the same. The lines are parallel, which means there is no solution to the system of equations. Okay. Go ahead and see if you can answer the discussion questions. I'm going to actually end my video here. I'm going to have you fill in the discussion questions on your own, and we will talk about them in class, or you can talk about them with a partner. To summarize this lesson, parallel lines do not intersect. A system of equations that produces parallel lines will have no solutions. You verify your slope and your y-intercept, and no solutions will have the same slope, but not the same y-intercept. So this was a quick and easy video for today. I do want you to go back and just take a few minutes and answer these questions. Some of them are going to be very, very redundant, which means that it's kind of saying the same things over and over again, but the more times you say it, the more times you repeat it, the more likely it's going to be to stick in your brain. So you will be doing the on your own questions on page 291 and 292. as well as the independent practice in class. So have a good night, and I'll see you in class.